to our PowerPoint. Okay, to repeat, a phospholipid is the main component of cell membranes. This is phosphorus here. This is called the head of the phospholipid, the hydrophilic portion, because it dissolves in water. This is the hydrophobic hydrocarbon. It is repelled by water. So a phospholipid has a phosphate group and some nitrogen, and these two hydrophobic tails. Now, proteins. Okay, let's talk about an amino acid. Amino acid is the building block of proteins. Every amino acid has a central carbon, a carboxyl group, C double bond O, C single bond OH. The amino group has nitrogen and two hydrogens. So that's the structure of an amino acid. If you have two individual amino acids, dehydration synthesis will remove water and build a peptide bond between this carbon and this nitrogen. That's a peptide bond. If you put long strings of amino acids together, you have proteins. So if you have 8 different amino acids and put them together, their structure determines the ultimate shape of the proteins. Proteins are long chains of amino acids, and depending on what amino acids are present, that determines the shape and activity of a large protein. So R groups interact with neighbors and with solvent. The amino acids chains will have a different shape depending upon what amino acids are here. Enzymes promote reactions, but they're not used up. So they have an active site. Substances can be brought to that active site. S1 and S2, called a substrate, bind to make a product, and that product detaches from the enzyme. That can be repeated many, many times, and the enzyme is not used up. It just promotes the reaction. Okay, that's enough on that. I'm not worried about nucleic acids at all. So let's get rid of that. Need more time, yes. And where am I? Let's go back and turn off recording. We'll have another separate stop recording. And there we go.